Research to be published tomorrow will say that we have grossly underestimated the risk to this country from floods. But precisely how much worse will climatic conditions get? Scientists studying global warming mostly agree temperatures likely to rise by a couple of degrees Celsius. But to be more accurate, they say they need 1,000 times more computing power. They say they would, wouldn't they? It'll be cheaper to buy new computers to predict if we need a new Thames barrier than it'll be to build the barrier itself. But as our environment analyst Roger Harrabin reports, it's not necessarily that simple.
Planet Earth, the most complex system we know, or don't know. So many factors affect our climate: our proximity to the sun, the Earth's tilt, the carbon cycle involving plants and the oceans, clouds, the winds, the currents, and now our greenhouse gases, which most scientists agree will continue to heat the world. The Met Office Hadley Centre in Exeter uses computer models to predict how the natural world will react to any man-made warming. The models here have become increasingly sophisticated over the years.
Back in the 1970s, the models that we had just included the atmosphere and rainfall and the amount of carbon dioxide being emitted into the atmosphere. By the mid-1980s, we had clouds in the model, land surface and ice. By 1990, we had a very simple ocean. And by the mid-90s, we also included the sulfate aerosols and volcanic eruptions, and also an ocean. By the year 2001, we had more complex processes in the ocean and better representation of clouds. And now we are able to include chemistry and the feedbacks of the carbon cycle.
So what does the future hold for the climate? Well, all the models, even the most conservative, foretell of warming. All the models, except the most conservative, foretell a potentially dangerous warming. That's what's created the new political urgency over climate change. But for all their strengths, the models are still a work in progress.
So what do they show? If we double CO2, how hot will it be? The Bible's the Intergovernmental Panel on Climate Change. Their most conservative model shown here suggests almost 2 degrees of warming. The top end assumes a warming of more than 7 searing degrees. Most model dots cluster around a rise of about 3 degrees. This could lead to 1 billion people thirsty, widespread death of coral, 1/3 of species facing extinction, and massive melting. But it's a complex planet scientists are striving to understand. These are pictures from NASA, but not a satellite image, a computer animation instead, run at high resolution for short time spans at serious cost, projecting even how hurricanes would form in a warmer world. At Reading University, they're collaborating on a long-term climate model. Unlike the NASA model, this one projects changes over decades. The yellow dot at the bottom is the daily sun. Increased computing power should mean more accurate forecasting. And Reading are just installing their own multi-million-pound monster, IBM's Thames Blue.
How do you feel when you come in this computer room?
Well, I feel the excitement for the opportunity to use such a new and powerful machine.
This beast does 20 million calculations a second. It has 20 teraflops in geek speak. It's like having thousands of PCs, and it's raising new possibilities.
We can now model weather in the climate models. If you think of maybe a parallel with the world of digital cameras, what we normally have in climate science are very coarse, very low megapixel type of cameras. With the big supercomputers, we can look at weather and climate as you do with a very high megapixel type of camera. I think it's very exciting because it means that we can actually calculate the probability of a storm like Katrina hitting a particular place. You know, how many times in a century? We can start to answer those questions.
But to understand the future climate, brute computer power is not enough. The computer is slave to its master's knowledge. Some of our knowledge of the great Earth systems is solid, some is more flimsy. Take clouds. They play a major role in climate modelling.
We know low-level clouds are more reflective. They bounce back the sun's energy into space and so keep us cooler. High-level clouds tend to trap in more heat radiating out from the Earth. The big question is, what sort of clouds will predominate in a warming world? Here are the models of cloud feedbacks in that IPCC report. All but one are above the line, predicting that clouds will accelerate future warming. But what if most models are wrong? What if clouds mitigate warming? Then the climate might still warm as emissions increase, but not so far or so fast.
The climate modelers themselves admit that the biggest uncertainty in global warming forecasting is how clouds will respond. And the fact is, we just haven't had very good data, which has to be from satellites because you need global data to answer this question. We just haven't had very good data for more than about 6 years pertaining to clouds.
The modelers say their knowledge of clouds is increasing fast. They reject the notion that we really don't know clouds at all.
The basic physics is well known, is what allows us to do weather forecasting every day. There is of course uncertainty, and that uncertainty depends on the fact that we all code in these laws in a slightly different way. That's why we have so many models, and that's why we intercompare to establish what the uncertainty is, to quantify the uncertainty.
The carbon cycle is another key area of uncertainty, the great system in which the Earth and life upon it breathe carbon in and out.
We have to try to model an immensely complex system, all the way from the tropical rainforest, the oceans, the northern hemisphere forests, the soil, and we have no fundamental equations to do that with. Whereas when we are modelling the oceans and the atmosphere, the physics of the oceans and the atmosphere, we do have some fundamental equations. We don't have those for the living parts of the system.
Here's our sketch of carbon cycle feedbacks from the Met Office Hadley Centre. The black line shows our CO2 emissions that are projected to heat the Earth. But how will the planet react to extra heat? The red shows how plants and soils will release more CO2 as the world gets hotter. And that feedback will make it hotter still. The thick band reveals the uncertainty. But all the models agree that as we turn up the heat, we get extra CO2 from plants and soils. Ocean currents add more uncertainty. New German research suggests that natural variations in the Atlantic might hold back global warming until 2015, when temperatures will rise again. And on top of all this uncertainty, there's also uncertainty over policy.
Even if we assume that man-made global warming is going to be serious, there is nothing substantial we can do about it without some sort of new energy technology. It doesn't matter how many compact fluorescent light bulbs you use, how many hybrid cars you buy, even converting from coal-fired power plants to nuclear power plants, it's still not going to get you to where you need to be, which is at least a 50% reduction in carbon dioxide emissions.
There is plenty of uncertainty, but if we wait until we are certain, we may wait too long to avoid the most dangerous outcomes, and I think that would be a very unwise course of action. We only have one planet.
Uncertainties do remain over exactly how much the Earth will heat, but the important debates about clouds and the carbon cycle may not be fully resolved for a decade or two, and by that time it would be too late to cut emissions to prevent the worst disaster scenarios.
That's why this debate is now mainly with the politicians. World leaders agree that emissions should be cut, even though in reality emissions are continuing to soar. It is an experiment with the planet. How will it end? The modelers say they need 1,000 times more computing power so they can find out. The answer may lie in the clouds.